Very good day and great to meet. We are from Group ACES and we'll be presenting our project titled Data Wrangling and Visualization on ACES. Next, I'll pass it to Junwei to start with the presentation.
Thank you, Pepe and Junwei, to introduce this project. It simulates a real-world data analysis scenario where we take on the role of data analysis to extract the meaningful insights from the raw transaction data on the cafe. The process involves the data wrangling, cleaning, creating, and structuring messy data, and visualization using the charts and plots to reveal the pattern on threads. We analyze the customer purchase, pricing, quantities, payment methods, and dining the preference across different days. Our goal was to uncover insights into customer behavior, operational threats, and seasonal patterns to support the better business decision and improve the customer satisfaction.
My name is Zia and I'll be sharing the dataset selection and business understanding introduction. The dataset used is a synthetic dirty cafe sales dataset from Kaggle. It contains 10,000 rows of fictional cafe transaction, including details like transaction ID, item quantity, price per unit, total spend, payment method, location, and transaction date. This dataset provides a realistic scenario for practicing data cleaning and analysis. It allowed us to explore customer behavior, sales trends, and operational patterns in a small business context. The project focused on 3 key areas: data cleaning, exploratory data analysis, and actionable business recommendations to improve efficiency and customer satisfaction. For data wrangling, first is initial data issues, found missing values, incorrect entries, and wrong data types, and some numeric columns stored as text, so df-info is used to confirm inconsistencies. Second will be cleaning steps, replace dirty values with NaN, convert quantity, price per unit, total spend to numeric data, fill missing numeric values, and recalculate total spend. For the third will be categorical handling, fill missing value in item, payment method, and location with mode, convert transaction date to date time, and forward fill missing dates, and remove duplicate rows. Lastly, for feature engineering, we created new time-based features, which is day of week and month, and this results in a fully clean dataset with proper data type and function.
Thank you, Ian. The goal of exploratory data analysis is to identify patterns, detect anomalies, and explore relationships between variables. We began by summarizing key numeric columns such as quantity, price per unit, and total spend to understand their distribution. Most customers buy 1 to 5 items with an average quantity of 3. Prices average $2.95, typically ranging from $1 to $5. Customers spend about $8.95 per transaction, mostly under $15. The pie plot here shows the juice is the top selling items, indicating potential for expanding offerings, bundling with lower selling items, and running cross promotions. Digital wallets are the most preferred payment methods, highlighting an opportunity to offer exclusive discounts or cashback to boost usage and streamline transactions. So the first figure here shows that takeaway orders account for 70% of sales, suggesting a strong preferences for convenience. In-store sales, which takes 30%, can be boosted through better ambience and exclusive dining offers. Second figure shows Monday has slightly higher sales, but overall transactions are evenly spread across the week, supporting consistent staffing and targeted weekday promotions. Next, left figure shows most purchases are under $15 with a few high spenders. Another figure highlights sales peaks in June, October, and December, while February and September are slower. This trend supports seasonal planning for menus, staffing, and promotions. That's all for EDA part. Now I'll pass to Pepe to continue.
Thank you, Xin-En. In this section, we use box plot to visualize the spread of quantity, price per unit, and total spend. While no outliers were found in the first 2 images, while in the total spend box plot showed some extreme values. Therefore, we applied the interquarter range method to confirm this and identified there are 240 of the outlier rows. Okay, so this is important because outliers can skew analysis and affect the business decision like pricing or promotions. Next, we analyze the total spend outliers more closely using box plot grouped by the payment method and day of the week. We found that high spending transactions over $20 occur across all payment types and also throughout the week. Therefore, these outliers are not tied to specific days or promotions, suggesting that they are part of normal customer behavior. To further validate these outliers, we reviewed the top and bottom rows of the flat total spend data. Most of these outliers were transactions where customers spent $25, the maximum amount in this dataset. This confirms that the outliers are not errors but rather valid high-value purchases and therefore should be retained to accurately reflect the spending behavior. Next, we use histograms to visualize the distribution of quantity, price per unit, and also the total spend. The quantity chart shows a balanced distribution with 3 being the most common, reflecting the consistent purchasing habits of the customer. Price per unit peaks as $3, indicating that most products are priced at around this range. For the total spend, the data is right skewed, with most customers spending under $15 and a few spending up to $25. And now I'll pass it to Junwei to continue.
In the data visualization, we also propose the density plots. It shows the quantity and price per unit both display sharp, narrow peaks between 1 and 5, indicating that purchase and price are concentrated around a few standard values. This will be in the line with fixed menu price and small purchase quantity in the cafe setting. The pairwise scatter plot provide an informative and concise visual summary of the relationship between the numeric variables of the dataset, quantity, price per unit, and total spend. One of the stronger threads observed is the positive linear trade between the quantity and total spend. This makes sense intuitive when a customer purchases more items, the total spend usually will increase. The heat map shows a strong positive correlation with 0.71 is observed between the quantity and total spend. This indicates that as the number of the item purchased increase, the total amount spent also. This relationship is important for understanding customer purchasing behavior in a transaction environment like a cafe.
Thank you, Junwei. The exploratory data analysis and data visualization of the cafe transaction dataset has revealed some business insights and recommendations. Juice is the top-selling item, ideal for promotions and bundles like a juice plus cake combo. With an average spend of $8.95, the cafe could introduce tier loyalty programs such as the cashback for mid-spenders and rewards for those spending over $25. Digital wallets dominate payment methods supporting e-wallet promos to boost usage. And also, as 70% of the orders are takeaway, mobile pre-orders and grab and go bundles can improve efficiency. Sales are steady throughout the week with a slight Monday peak, making Monday specials strategy effective. And also, the June, October, and December show sales peaks, while February and September are slower, suggesting opportunities for seasonal promotions and limited time deals. That's all from me. Now I will pass the floor to Junwei.
To enhance the analytical depth beyond traditional exploratory data analysis, a predictive modeling approach was employed using the linear regression, aimed to estimate the total amount spent based on the quantity purchased and the price per item.
This slide shows a scatter plot comparing actual versus predicted spending values visually confirm the model's reliability, with points closely aligned to the ideal prediction lines. There are minor deviations at higher spending values were observed, which may be due to fewer high-value transactions or data noises. So in conclusion, for our project, the full data pipeline is starting from data wrangling, then the exploratory data analysis, visualization, and lastly, the predictive modeling. So for some of the limitation are no customer ID in the dataset, which limits the behavior tracking, and no geographic context, which limitation to explore the impact of external contextual factors such as weather. So for the recommendation will be add customer demographic for better segmentation, integrate external data such as events or weather for context, and use result for loyalty rewards, bundle sales, and targets promos. So that's all from us. Thank you.